Good evening, Errol.
Hey, Howard, good morning.
Hear me?
Yep.
Yep. Okay. Thank you. Mayor, is this your first time? Mayor, you're on mute if you're talking.
Yes, it is.
Okay, welcome aboard.
Thank you.
We'll ask you for a brief introduction shortly. Give us a chance to get started, but
Okay. You want me to introduce myself now or later?
no, in a moment. Let's wait for a few people let's wait a few minutes to get everybody online.
Okay.
Thanks. Dan, is this your first time as well? Dan Rower?
Hi there. No, I've been on a couple of these.
Okay, sorry, I don't seem to have you in my list.
Oh, I've been sneaking in stealthily.
Is that what it is? Okay, I'll corner you to introduce yourself later.
Sure.
And Frank Costello as well. Is that you? Is this your first time?
Yes, good morning. Yeah, it's my first time. Yeah, thank you.
Okay, great. Nice to see all the new people.
Thank
The Loats in strength. Michael, good morning, Michael.
Good morning, Alan. Hi, everybody.
RPO, is this your first time? Just joined us.
Yes, it is.
Okay. they'll ask you for an intro as well in a moment. I think I have everybody. 8:04, give it one more minute. Good morning, Victor.
Morning.
I'm a little bit disorganized this morning, a little bit late. Okay. All right. I think I'm about ready now. Well, good morning, everybody. Let me just share the screen. There we go. Okay, yeah, so welcome everybody. This is our OCP High Performance Compute Subproject regular meeting. Today, we missed a meeting a couple of weeks ago because I was at the OCP Regional Summit. In the end, I didn't present there, but I did chair the IT infrastructure track, the server track effectively. And that was quite a good event actually in terms of catching up with people on various aspects of the racks, and there's Europe has quite a focus on the liquid cooling, etc. Just in the interest, I'm still progressing our sort of deployable bring up concepts that we've been talking about for a few months now, and there are some things changing around which I'd like to touch on. In terms of the way that DCMHS is going and what we might be able to do there. And in that, the key thing that is now sort of driving my focus is the external PCI cabling between boxes, specifically for PCI Gen 6. And, you know, there's several ways we can skin this cat in terms of this deployable bring up platform. I think the simplest is with just manual cables rather than blind mate backplanes. But obviously, if the OCP Open Systems for AI infrastructure does come out with a standard for backplane cabling up and down the rack, then we might be able to jump on that. But that's I'm not sure that that's going to be out anytime soon. So I was looking for a simplistic manual cabling approach, and obviously PCI SIG has been busy with various external PCI cable standards, and so I wanted to bring that to the fore today and discuss some options there. And what I'm seeing out there is in PCI Gen 5 stuff and what's happening with PCI Gen 6. So that's the main focus of the meeting for me today. But before we get started, we have a few new members, so welcome aboard. We always like to hear from the new members, just to briefly introduce yourselves, their affiliation, what their role is, and their interest in attending this meeting. So I'll look down in no particular order. I'll start with Frank Casteller. Would you like to start, Frank?
Yes, good morning. My name is Frank Casteller. I work with Schneider Electric. I'm a solution architect, and I'm here basically trying to understand all about an open compute project.
Okay, in general.
In general, yes. Understand the architecture, all the challenges that we all have, and also opportunities, of course.
Great. No, welcome aboard.
Thank you so much.
I'd like to talk to you. I think one of your colleagues that's been fairly involved with OCP as I've spoken to in the past, but certainly on the infrastructure end in the racks, there's certainly some questions I have. So it'd be nice to talk to you. Okay. All right. Thank you and welcome aboard. Next is Damir Klikic, is it?
Yes, hi, my name is Damir Klikic. I am also with Schneider Electric. I'm part of CTO office. This is my first time joining, and I'm also trying to learn about the sub-project if this is something that I can contribute and learn at the same time. My expertise is in power electronics, power conversion.
Okay. Excellent. Okay. Actually, all the new guys that are attending, one of the things that we can potentially do, because we've got some of our more radical stuff that at the moment is sort of a little bit parked, whilst we look at these bring up ideas in more of a I guess a less power dense or less performance power dense architecture. But it would be great to talk to you guys, especially on the power side of what we call our wall of compute. So I can probably point you all to some videos from the various OCP summits that would get you quickly up to speed. And I'd be delighted to have a chat with you, just a one-on-one to sort of fill in the gaps and bring you up to speed at the things we've been looking at. I do want to get back to the dense implementation sooner than later, and power and thermal are, from an infrastructure perspective, are two big pieces of that in the thinking that we've had, why we've come up with what we've come up with. So maybe we can touch base offline. That's Damir. The next one is new, would be Dan Rower.
Hi, yes, I lied earlier when I said I'd been to this before. I'm confusing it with another
Okay.
similar forum on Zoom. So I work at Schneider Electric along with Frank and Damir and others. I head up the architects for kind of a segment of our business. So that'd be what we call rack systems. That includes, conventional rack power in the racks and also the single phase UPSs. So I am not so deep into the designs anymore these days. I'm more working with the architects that are deeper into the designs. And so I definitely, anybody in this industry needs to keep their thumb on what's going on with OCP. And so that I include myself among those.
Excellent. Well, glad to see Schneider and Mass here. So, yeah, well, that's great. Well, we should definitely get together. And RPO, would you like to introduce yourself?
Sorry, I was muted. So yeah, I put my name there. RPO. My name is Raul Pombo. I'm the principal product strategy manager for Penduit, and I participate in the Rack and Power community also too. I was interested actually to, I guess, to participate or at least call into this subgroup. It looks like it's server driven. I wanted to get a little bit more understanding what OCP is doing when it comes to adopting for the server technology, adopting the DC power, and be able to connect directly to the bus bar. So that's my kind of my interest, especially when it comes to high performance computing. So that's why I'm calling today. So
Okay, welcome aboard. And so,
thank you.
if you wouldn't mind, Raul, I probably butchered your name and the company. If you could put it in the text in the chat, I'll correct it later.
Okay, I put it in there also in the top also. I changed it to RPO. Sorry about that
Oh,
before.
yeah, I
Yeah.
see that
Yeah.
now.
You see it
Oh,
there? Yeah.
perfect, perfect.
Okay.
Okay, there you go.
Okay.
I'll
All right.
correct that in a minute. Okay, well, welcome everybody. I feel as though I should be a little bit more prepared in terms of just giving you guys a quick idea. But let me just think. So I think if I can maybe actually the four of you that are new, I'd love to just schedule a separate offline call with you so that we can I can really give you a little bit better pointers and bring you a bit more up to speed. But just to suffice, where we're at in the OCP high performance compute sub project, I've been running this bizarrely for about 4.5 years now, but really we've taken quite a radical view of the world of compute and said, if we had the beauty of a clean sheet of paper, how would we re-architect the data center from the ground up? And we have come up with some quite interesting concepts where literally we would get rid of the 19-inch racks and we'd replace it with something we call a wall of compute. So that has been, and over the years, several companies have come and gone, including the likes of, well, all companies really, but another large one that comes to mind is Boyd on the thermal side, but Molex have been involved. We've had participation from AMD and the various players over the years. And we've had experts sort of say that will never work, and we keep refining our concepts. So we got our concepts to a certain level where we actually did put in for some funding with one of the government labs, the Oak Ridge National Labs, on New Frontiers. We're still waiting to hear on whether they're going to fund the idea of trying to bring this concept to a proof of concept reality. But equally, the world is moving on at quite a pace, as we can all see when you look at what NVIDIA are doing with their Vera Rubin architecture in 2027, fully liquid cooled, etc. And but we've created some ideas that looks like have made their way into the next generation architectures from the likes of NVIDIA, etc. So I guess maybe we've contributed in some small way to their ideas because we're an open community. But if you follow OCP and specifically in the server group, there is a modular hardware system architecture, MHS. So it's called the data center MHS, and that's really was really focused on the classic server architectures, but more towards the ORV-free rack design, ideally, and modularizing the CPU and the IO and aligning with the new standards that have come along, like the EDSFF, the SSD standards like E1 and E3, and the data center security control modules and IO out of the box, making it more modular and as a result more cabled. I've in the work that I've been doing, I focus more on the accelerator end, including the GPUs. My background is FPGAs, and I've been consulting for a few of the well-funded VC-backed silicon accelerator startups, including the likes of Next Silicon and Untever AI. And when these guys get new chips from the fabs, they need to basically have a bring up platform. And when they get the chip up and running, they then need to make a deployable platform in some of these industry standard formats, like a PCI card or an OAM, etc. But in my mind, the path is quite slow in terms of getting a chip from the fab into a deployable product. So we took a little bit of a blend of what we've done and said, okay, let's be a little bit more incremental from our radical ideas with using stuff that already exists, but allowing, ideally, if we could define a process. So a chip comes from TSMC, from a fab to a silicon startup. They have a bring up platform and a bring up process that is efficient and quick, assuming their chip is, not dead on arrival, where they're debugging their chip and bringing up their chip rather than solving the system level issues. And if they can plug that into a sort of a standardized bring up platform, they could actually get through to deploying to customers in an OCP format quite quickly. So that's where we've been putting our focus over the last few months. On that, so I won't say any more on that. I mean, that's hopefully gives you a quick backdrop. Is there any basic questions around that, or does that make sense, hopefully, a little? Take silence as it does. Essentially, it does cover really looking at where everything from the infrastructure down to the individual chips themselves. But specifically with this bring up, we're trying to focus on ORV3. Admittedly, there is 19-inch DCMHS. We are looking at being able to support an accelerator in either the 19-inch or the 21-inch formats for brownfield installations, etc. as well. So that's stuff that we've got going on. As everybody who's following this is aware, there is this rack scale scaling now, scale up between multiple accelerators. And again, NVIDIA's NVL72 is where they've connected 72 of their Blackwells together through cabling up and down the backplane. So that's the topic of today that I wanted to get onto. We've been looking at PCI type IO, or at least the PCI connectors. The MCIO connectors is what we've been standardizing on because they're pretty well adopted everywhere in servers, etc. And we've been, through our other efforts, we've been trying to say, can we make a universal topology interconnect that can maybe carry all types of signals, and maybe we use the MCIO as our starting point, and PCI as our starting point. Is that's that's pretty ubiquitous. So again, for the people that have been here regularly, we've done quite a lot of work around the MCIO cabling, and we haven't really touched on the external cabling. So when we come out of the chassis and we want to go up and down the rack, how do we do that? So, and the guys from Lopes, I guess, are going to be the closest to this, and we've got a good few on. So, hi guys. I wanted to maybe start. Somebody pointed me to this SNIA document, which I believe is in collaboration with PCI SIG as well. And it's very fresh. This one's March 2025, so just literally a couple of months ago. And it talks about external PCI cabling. So in my research, traditionally, well, historically, PCI, external PCI cabling has been in, I've gone and forgotten the name of the format, but a fairly ugly format. And but more recently, in the later standards, a couple of companies adopted QSF-PDD cages and adapted them for PCI, external PCIO. And Molex in TE came up with something called CDFP way back in 2013, I think, which was for PCI external I/O. And it's looking like, to cut a long story short, it's looking like the CDFP standard is the one that is being driven forward by PCI SIG. And there is a by 8 and a by 16 version. It used to be only by 16, but there is a by 8 version now. So if I flash through, yeah, this is the old-fashioned connector that they used, but this is the new one. So this is the new CDFP format. Well, it's not that new, but this is the format. And there are two versions. There's a by 16 and a by 8 version. So this is just some details on it. So the way that I see it at the moment is that it's literally a PCB connector and obviously a cable on the outside. So the approach with this today is basically, hang on, let me look this up, is a PCI card, which typically will have a retimer or a PCI switch on it that feeds this connector, and then you can connect the cable to that. But obviously what we've been doing is we've been putting MCIO connectors as close as possible to the chip, and we're cabling our modules together so that we can actually give much more configurability of the interconnect topologies between the accelerators and actually go longer distances than obviously PCB traces, etc. And so one of the things that crossed my mind is anybody doing a bypass cable from an MCIO to a CDFP? And again, with our universal interconnect pinout that we've been discussing, could we leverage that if it was being developed for our universal interconnect connectivity as well? And so we could just have a bypass cable and get rid of the paddle card and ideally get rid of the retimer. That's the thinking. Let me just go up here, CDFP. I just want to show you something. So there we go. So one-stop systems have their own card here. Here's one. Assuming everybody can see this. So you can see that's got the CDFP cage, is soldered onto the board, PCI card, low profile, and it's got a PCI switch or a retimer chip here, and then it comes back to the rest of the system this way. So I would ideally rather this be a bypass cable going straight to an MCIO, would be the desire. And in fact, I'm talking to One-Stop Systems today, and I think they may have an interest in that as well. So I guess the most experienced people on the call are Lotz. I don't think Z's not on the call, is he? From Amphenol, or there's no other connector. So Howard and the gang is if you've got, do you have any? I mean, the other thing is this the standard that everyone's going down, or is there a QSF-PDD or an OSFP version, or PCI SIG seems to be driving this. So can you give any color to where we're going here?
Well, if it is PCIe, if it is sanctioned by PCI SIG, then it should be 1032, it should be CDFP. Now, but I mean, if you are looking for some other form factor, conceptually, I don't see why QSFP doesn't work. Now, but again, if you want to be like close to what the SIG is, at least in the PCI spec, then CDFP should be the one. And flyover cable, I presume, I think you mentioned is from MCIO flyover to CDFP or similar.
Right.
Ariel, correct me if I'm wrong. I do not believe Lowe's has a product today. That being said, I also believe that it's not difficult to develop.
Yeah, we don't have, excuse me, yes, Raymond, we don't have an actual product at the moment. What we do have is a design in place.
A bypass cable design.
The flyover, yeah. Yeah, I think that's the bypass cable you're referring to, Alan.
Yeah, flyover. Yeah, that, I guess it goes under different names. Yeah, flyover.
Yes, yeah.
Okay, so you have one. You have a concept already drafted.
We do have a concept. It's a work in progress, yes.
Okay, that's good news. That's a great start. Okay, and is that for the by 8 and the by 16, or just one or the other?
We're working on the by 8 at the moment.
Okay, even better, because that lines up with the MCIO by 8, I guess, right? Nicely. Okay, so in theory, then the work you've already done for us around the universal topology interconnect variations, which is really just the same connector with more differential pairs and less single-ended, I guess, would also be doable, I guess, in the same fashion without dramatic changes.
Well, the details is always, the devil is always in the details, right? So because of the MCIO connector that we developed for HPCM actually has a different pin map. There could be some implication on how it land on the CDFP side.
Right.
It may.
Right.
But that's part of the details that need to be flushed out if we are going down that path.
Okay.
And of course, also don't forget about the sideband.
Exactly. Well, no,
Think about that. We need to think about that sideband. What's
so
that need
that's
to
why I
go
was
over? Yeah.
that was the point. Is in our universal topology interconnect, we've got rid of the sideband, if you remember, and we've replaced it with the OCP LTPI, the LVDS tunneling protocol. And so that's a single differential pair or two, a transmit and receive differential pairs. So we set up there's an optional clock if you want to do a source synchronous clock implementation, or rather than the asynchronous clocks.
Yeah, what I'm actually implying is on the CDFP side, if it is PCI standard, PCIe standard, then there would be something that need to be supported on the CDFP side. So if when the cable fly over, what I'm trying to say is we cannot just keep focusing on the high speed. We also need to be mindful about how are we going to deal with the sideband.
Right. Yeah. No.
So that's what I'm trying to say.
From a standard PCI perspective, I get that. Yeah.
Yeah.
Yeah. But from our universal topology one, then that's less of an issue because the sideband are carried over this differential.
用它的 NIC 这个 Talent NIC 现在就是乌码比较大，但是
Hey, Bobby, were you chiming in there, or you can you go on mute?
Sorry, I need to mute.
Thanks. Yeah. So sorry. You were saying Well, yeah. So in your concept at the moment, are you saying you've got challenges with the sidebands, or I'm not sure I followed the detail of what you were saying.
So usually when we are doing the initial design, or as Ariel say, the concept, the initial focus are all on the high speed, the high speed differential.
Yes, right.
Now, but then if you think about it, you have a flyover cable. So does it mean all the sideband also come through the same set of cable bundle? Let's call it a bundle, right? Because if it is a, let's just pick one, right? By 8, we have 8 lanes, so that's ATX, ARX, right? Yada, yada, yada. But then for PCIe, you likely need to have something about the clock, maybe not. But then you have a whole set of something else that need to be connected. So is it going to be just fly over on the cable, like I said, or is it going to be some other way that get connected to the CDFP side? Those are things that we need to think about eventually.
Right. Now, I'm assuming as well that PCI SIG have an opinion on that.
Yeah, if you want to call it PCIe compliance, there are certain things that you just cannot go around, right?
Right.
Yeah.
Okay.
Just something to keep in mind.
Yeah.
Yeah. For example, right, it can be only the high-speed signal fly over, and then because of the CDFP receptacle got to be mounted on some kind of PCB to begin with, maybe something else that can be like route over through regular PCB, or maybe use some kind of low-cost cabling. It's just things that on top of my head that I can flow out, not that I'm suggesting anything. Make sense?
Well, yeah. I mean, maybe what we can do is, if that needs, well, again, I guess I have, in terms of what we're trying to do here, I think the one with standard sidebands is one implementation, which is pure whatever PCI SIG explicitly says, and the other implementation is our universal topology interconnect that we've sort of conceptually implemented on the MCIO. It's just taking that, which I would imagine would be simpler because it's just differential pairs then. There is no single-ended. So, I mean, I guess I'd like maybe if you've already got that work in progress, Raymond, then if maybe we could bring that to here to answer any of the outstanding questions that you have, or how it would work for us. Now, obviously, I'm assuming we don't want to duplicate what PCI SIG and SNIA are already doing with this. So certainly on the standard PCIe, we just want to follow what they're doing, right? So
Yeah. So as soon as you have some more detail, I mean, conceptually, like I said, right, we can develop it. It shouldn't be a problem, even if it doesn't match up with what we have already done. I do not believe it will take a lot of work to do some modification and fit what the HPCM need.
okay.
So whenever you have more detail about what it should look like, we can talk. And by the way, you mentioned retimer. I think that is not on the receptacle side. It would probably
yeah,
on
no.
the cable side.
In a bypass, in a flyover, the idea is we don't need retimers. I'm trying to get rid of the need for retimers. But typically, if you put a paddle card, you almost force yourself into having a retimer because of the signal integrity loss through the paddle card itself. Because you're adding another layer of interconnect then.
Yeah, what I'm saying is it may be the retimer or in general the repeater maybe it's on the cable plug panel card.
Oh, on the cable itself. Yeah, no, even better. Right, right.
Yeah, so it's an active cable.
An active cable. Yeah, no, I completely agree. That would be where you'd want to put it. Basically, if you had a short cable, you say, I don't need one. If you have a long cable, you say, well, let's use a cable with a retimer in it. So completely support that. But then we have to carry the power as well over the flyover cable.
Yeah, I think you start to get my point.
Right. Okay. Now that's fair. All right, and I see Bobby Lou. Is that you, Bobby, on the call? Light Intelligence.
Yeah. Hey,
Hey, Bobby. So
Yeah.
we're talking about. I saw you joined a bit later. We're talking about external PCI cabling, and obviously you guys have got your optical one. So are you building a CDFP optical?
We already have one. We already have the CDFP AOC by 16.
You do. And
Yeah.
are you doing a by 8 as well?
We didn't build by A because I think the by A is using a different connector instead of not the CDFP. It's using another SFF connector. We have the by A using a QSFP DD connector. However, the QSFP DD connector pin list is not officially get approved in the PCIe workgroup yet. I know Sam is working on finalizing the pin list, but it's not officially been published yet. So that's why that's why you probably only see the CDFP on the PCIe 6 website.
Right. So thanks for that input. That's a good bit of input because now you're talking PCI Gen 5 here, Bobby, right?
That's right.
So I was also familiar with the QSFP DD implementation for the by 8. And I saw that it was unofficial, i.e. outside of PCI SIG. But in talking to, I'm talking to Jan at One Stop Systems, who they build cards for this because they do PCI expansion chassis, and he seemed to be indicating that for PCI Gen 6. Everyone's sort of dropping the QSFP, or he didn't explicitly say that, but in this spec that I'm sharing on the screen right now, they've made a specific by 8 version of the CDFP. Here it is here. So it looks very much like the by 16, just slightly narrower.
Yeah.
And so it looks like for Gen 6, which is where we're looking, it'll only be CDFP and they'll drop the QSFP DD. Is that your view, or do you think they're going to do a Gen 6 one in the QSFP DD as well?
I think it's right now, from what I'm understanding, is the QSFP DD. They will likely be like an additional addendum from the standard spec. So that means if people want to build a QSFP, they can build and at least have some pin layout agreements and all the something to talk about. But the official spec will still follow the current PCIe Gen 5 standard, which is
I guess for me,
CDFP.
Yeah, I guess for me, the $64,000 question is if we do go down this, and I know that MCIO is trying to get to 100 gig speeds, but if we do end up going down this channel of a universal topology interconnect where it's not just PCI, it could be Ethernet, it could be NVLink, UA link.
Yeah, I think the problem is the PCIe also have to cover the copper cable connector, and in for that's why the CDFP is kind of a preference one for the copper cable. From optical people point of view, there is a downside for the CDFP because the nature of the power supply chain. The CDFP only have one 12-volt, one 3.3-volt, unlike the QSFP-DD or OSFP, which is also 6x16 that has more power pins on top of that. And also the cage design, the CDFP doesn't have is not designed to dissipate more than 15 or 15 watts or something. I think the spec is somewhere around 15 watts. But for QSFP-DD and OSFP, they're capable to design to dissipate something like a 20 to 40 watts of that. And so when you're talking about something like 100 gig that when we're talking about the MCIO, right? And then you have 516 over there. Then if you consider the optical cable that requires something like 5 picojoules per bit or 10 picojoules per bit, times that many amount of bit, it actually needs quite some powers to drive that.
Right. That, by the way, thank you, Bobby. That's fantastic input. And Raymond, I guess that plays to your your statement about the power for the active copper. Okay, you know that what you've said, Bobby, I think really does ring true and does make. Now, the other thing about the QSFP-DD approach is that it's already been in production in bypass cables forever, right? So it's, I guess, in terms of adapting it for our needs to an MCIO at the other end wouldn't be that much of a challenge. The other interesting thing here in listening to you is you said the reason why the QSFP-DD isn't popular for copper, I guess, is mainly because of all of those extra sidebands you have to bring out, which the QSFP is natively just the transceivers and nothing else, right? Which I guess you can sort out on the optical. You modulate all that, where you do have extra fibers, but you're not challenged in terms of the space for all the cables coming out of the slot, out of the connector.
Yeah. I think it's just the CDFP is more friendly to the copper, and then the QSFP, you know, it's more friendly to the optical side.
But that said, if we went to our universal topology interconnect pinout, where we get rid of the sidebands and roll them all up into this LTPI, this LVDS tunneling protocol with all the sidebands over it. Well, that will also play more nicely into your needs in terms of modulating all these onto a single fiber. Then that may be more appealing, and that may work with a QSFP-DD or an OSFP.
Yep,
for the copper.
Yep, yeah, for that, yes.
All right, so I guess. By the way, I think Ray and Lotz, or the Lotz gang, I mean, talking to Bobby and possibly if I'll be talking to Jan Manik from One Stop Systems today as well, so I'll be able to get his view. But if we could club together, I mean, on the basis, so what you're saying, Bobby, is PCI SIG are not actively doing this, but they would be happy to take input if somebody brought something defined into the PCI SIG. Is that what you said, or is this something?
I think it's not like I think they're doing it, but you know it's not official yet on the QSFP-DD definition. Sam Sam from Amphenol. He's leading the effort.
Who is, sorry, did you say Samsung or Samtech?
Yeah, Sam Cusco, from Amphenol.
Oh, right. Oh, so Amphenol is leading it. Okay, okay. So it's a shame that Z's not on the call then.
Yeah.
Okay. Well, if Amphenol, well, C and Z's normally on our call. So Raymond in Lotes, if you looked at the PCI over QSFP implementation as well or not?
I don't think we have any concept done. I need to double check. CDFP, yes. QSFP, I am not entirely sure.
I presume you have QSFP flyovers for Ethernet.
Let me check. Let me check.
Okay.
Yeah.
Well, so Bobby, I mean, if Z is, I guess if he's doing it inside PCI SIG, then great, right?
Yeah.
I mean, perhaps we can support that, I mean, or perhaps I don't know how we can get involved. I definitely don't want to take over the standardization, but equally, if we can get our universal topology interconnect ideas into that for the copper implementation. I mean, in my mind, although I see why the optical implementation in the QSFP-DD is great, without a copper solution, I think the value of the interconnect becomes less, right? So that you can just literally swap cables is the idea between copper and so short cables would be copper passive. You could do a longer cable with copper active and or optical active. So,
yeah, I agree.
So and then if we could get rid of all these damn sidebands and actually just put them over this LTPI, and actually agree this is the best electrical way to carry the sidebands. All right. I mean, so to be honest, on the one front, I sort of think, well, just going with the flow of the of PCI SIG, this is a spec. So I guess that and by the way, just to make doubly sure, we're talking about PCI Gen 6 here, right? So we need to make sure we're clear that that's the we're not looking in the rearview mirror at PCI Gen 5 is my point. Okay, well, I mean, in terms of our next steps, I think if Bobby, Raymond, and we can get Z on the line, and maybe perhaps Bobby, you could get maybe you could have even a separate meeting if you can get the Sam from Amphenol that's sort of leading the charge on this. That would be good to maybe get them on. In fact, if he could maybe present what they're doing, what they're trying to contribute, and whether we can steer them to our universal topology one as well, or at least supporting ours is whatever else they're doing.
Okay, yeah, I can loop you in. To get at least get an email. Go ahead, start it.
Yeah. Because I certainly have the use case here. Now the only thing with QSFP-DD and OSFP is they are actually longer cages, aren't they, than the CDFP? I'm guessing. Yeah, I think they are. Although I think there is a long version of the CDFP for optical. So maybe it's a wash. Okay. All right. Well, lots of food for thought. Well, that's a great first kickoff on this. And a lot more promising than I was fearing. So we do have bypass options. It's actively being worked on rather than just paddle cards. So that's great. Great. I think that's enough on that one. Just while we've been on, I've noticed we've had a few other people jump in. Jarrett Pivaronis, is this your first time?
Yeah, sorry, but my supervisor forwarded this meeting invitation to me a little bit late, so I joined in a little bit late. But I'm a business development manager representing Sanmina, the North American Cables division.
Okay. And nice to meet you.
Nice to meet you too.
All right. Just Frank. That was Frank Costello, right? Sorry, no, that's your Fabrico.
Jarrett.
Your Fabrico.
I'm Jarrett.
Oh, hang on. There's too many names here. I've got a bunch of new names. Hey, there you are, Jarrett. You've moved because you're talking. You moved to the top of the list. That's why I lost you. Jarrett Pivar. Goodness. And I see a couple of others. Fabrico Borges. I think you joined late, and you're new as well, are you? Fabrico, you're on mute if you're talking. No, maybe he's away from his phone. Okay, and Frank Costello, introduce yourself. Raymond. Okay, I think I've got everybody. Yeah, okay. So I think that's mainly that was my main topic for today. I've got enough to move the ball forward, and yeah, let's I'll try and do some more work on that offline, and maybe we can circle the wagons on an upcoming meeting. In the meantime, the Snyder folk and anyone else that's new, everyone that's new today, if you let me just pop my email into the chat. If you can send me, if you can email me with your contact details, or even pop it straight into the chat, that would be good. I can give you mine. That's me. If you'd like to either add it to the chat or email me, I can maybe I can send out an email to you all and give you details on where you can get up to speed on the other stuff we're doing, and I can talk more specifically about your interests on the power or infrastructure side and what we've been doing, and whether you can help us on that front. Okay, anything else from anybody? All right, guys. Well, we call it a day. Thank you very much.
Great, thank you, Alan.
Thank you.
Thank you so much. Thank you.
Cheers. Thanks.
Thank you. Bye-bye.